Alright, hi and welcome today, you guys. Today we'll be talking about permutations and combinations. But before we talk about that, let's talk about factorials. Okay, now factorials, or n factorial, is actually this formula right here. It's multiplying by every number below n all the way to 1. For example, 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. Okay. Now we're also going to talk about something called permutations and combinations. Now, permutation is a set of objects in which position or order is important. Like, for example, winners in a race. First is different from second, which is different from third. Okay, combination is a set of objects in which position or order is not important. So I'm going to use another sports metaphor. For example, when you watch during the Olympics and they have trial runs and they have a heat and the top 8 go, it doesn't matter which order you go in one of those trial runs because you're just trying to advance to the next stage. So as long as you're in the top 8, you're good. Okay. Alright, and now I'm going to give you the formulas for both of those. Alright, so here's the formulas for permutation and combination. Now, some important facts. Remember, n is the total and r is what you want. Okay, so and this is also how we plug it into the actual Desmos. So if you wanted to plug it into Desmos, you would type NPR, then parentheses, then you would choose that first. So let me type that in, those instructions. So in Desmos, if you wanted to use that calculator, you would type NPR, just like this, and then you would have your parentheses of N, comma, R. Okay, and then the same thing goes for combination. Okay. Alright, so that's how you put in the Desmos. So, real fast, NPR is basically n factorial divided by n minus r factorial. Okay, and this is when you're finding a set of objects in which position or order is important. Okay, so now some special cases. NP0 is 1, NP1 is just n, and NPN is n factorial. Okay, and remember, n is the total amount of objects you're dealing with. Okay, so if we're talking about a race where 20 people are in it and we're picking 10 to move on to the next heat, this would be NP10, which would be 20, no, it would be 20 pick 10. Okay, and we just move on from there. Now, combination is a set of objects in which position or order is not important. Okay, so there's two ways that you can write this. NCR, or parentheses with n over r, and that is equal to n factorial divided by r factorial times n minus r factorial. So this is the new part. Okay, right there. Alright, so now some special cases of combinations. NC0 is the same as n choose n, which is 1. Alright, n choose 1 is equal to n choose n minus 1, which is just n. And n choose r is the same as n choose n minus r. Okay, now I'll actually make a very good case for why this is this way. It's really kind of cool. Okay, so this whole thing is all set up. Now, I like to use the fundamental counting principle, especially when we're talking about permutations and combinations. Fundamental counting principle is if you have to make choices on something, could be choosing dinner or what to wear, just multiply the choices, the amount of choices you have. Okay, just as simple as that. So that formula is really easy. Fundamental counting principle, really easy. Permutations is just a set of objects in which each position, order, or order is important, and combination is where order and position are not important. Okay, on the next slide I'll show you how combinations actually come about. Okay, so combinations actually comes around from Pascal's triangle. So Pascal triangle. Okay. Ooh, triangle. Maybe I should work on my spelling real fast. Okay, so I'm going to use a pretty simple method. So if you pretend this up here is 0, the 0th row, this is the first, and this one's the second, and then this one's the third row, and then the fourth row is right there. Okay, so here's how it actually works. So if I had to do 4, choose 2, okay, so I would literally go to the fourth row Okay. And so what's happening is now that we've gone to the fourth row, I'm going to start out this as position 0, this 4 is position 1, and this 6 is position 2. So I'm going to use this information, the 4 and the 2, to divine that this is actually going to be 6. So I actually don't need a calculator to do this. I could just look at a Pascal's triangle and be able to get it. It's really, 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 really kind of cool. Okay. Alright, but let's just do some formulas just to actually show. Okay, so we're looking at this question. Jolene is on a shopping spree. She buys 6 tops, 3 shorts, and 4 pairs of sandals. How many different outfits consist of a top, shorts, and sandals can she create from the new purchase? Okay, so we're actually purchasing something and making choices from that. So if we have to make choices on something, multiply the choices for the total amount of combinations. Okay, so she has 6 tops, 3 shorts, and 4 pairs of sandals, and that is going to be 72 combinations of outfits that she could have from just this one shopping trip. Okay. Alright. Now, what is the total number of 4-letter arrangements of the letters M, A, T, H if each letter is used only once in arrangement? Now, if you notice in this one we do care about the order. Well, this one's kind of interesting. It's the total amount of number of possible 4-letter arrangements of the letters M, A, T, H if we only use it once. So this is actually important. So we can't use A twice, we can't use M 3 times or T 4 times. We just have to actually put them in order. So this one, order does matter, but we're not trying to make an actual word. Okay, so this is going to be kind of unique. So this is going to be this is going to be a permutation. So this is NPR, and you're going to put it as 4, and you're going to pick 4 spots. Okay, now this is also going to be the same as 4 factorial, if you remember from our special cases from earlier. Okay. All right. And it's going to be 24 ways to arrange the letters. Okay. All right. Now, this next one is a little bit easier to discern. There are 12 boys and 14 girls in Mrs. Schultz's math class. Find the number of ways Mrs. Schultz can select a team of 3 students from the class to work on in one group. The team is to consist of 1 girl and 2 boys. So this one's going to be actually quite interesting. So for the first combination, okay, there are 12 boys and 14 girls. So the first combination is we have 1 girl and 2 boys. So out of the boys, we can have, this is going to be NCR. Okay, now the order does not matter. If it's the first 2 boys, the last 2 boys, doesn't matter. So we're going to be using combination on this one. So we're going to take the number of boys combination, which is 12, choose 2. And we're going to times that by the number of girls combination, which is 14, choose 1. So this is how you put it into the calculator and just work it out. And this should turn out to be 924 is what you get from your calculator. Okay? Alright, that's it for permutations and combinations. Just remember, when you're choosing a team of 1 girl and 2 boys, or some team member like that, you're going to multiply your combination.